accepted, challenge accepted. Reality is always challenge accepted. Challenge accepted, challenge accepted. Reality is always challenge accepted.
AI is everywhere these days, but let's be honest, using it in real-life production often feels like juggling dozens of tools which doesn't really talk to each other.
That's exactly where the Model Context Protocol MCP comes in. It's a new open standard that allows AI systems, tools, and apps to actually work together. Think of it as the missing API for your AI stack.
Our next speaker will show us how MCP can root through the noise, reducing integration overhead, automating boring tasks, and unlocking workflows that are truly context-aware.
He is a senior engineering manager at StorPool Storage, leading teams that build blazing fast, highly available, and super scalable distributed systems used worldwide.
He's spoken at OpenFest, ISTA, HackConf, JS Talks, and today he's bringing us a fresh, practical look at how AI can be tamed with MCP. Please make some noise.
He's also one of our proud nominees for a Dev of the Year Award 2025.
Please make some noise for Nikolay Stoitsev!
Challenge accepted, challenge accepted. Reality is always challenge accepted. Challenge accepted, challenge accepted. Reality is always challenge accepted.
Hello everyone. I'm super happy to be here. Okay. And first I'm going to start with a story. I'm going to talk about one of the greatest physicists of our time, Richard Feynman. And he was very famous for doing physics. He was doing a lot of complicated physics all the time, right? Complex math, complex physics, inventing stuff. And sometimes he got stuck. Sometimes he loved physics. It was super awesome for him to do the math, to do the physics, but sometimes there happened that it was getting boring for him. Or he got stuck, he didn't know how to continue. And what he did in those cases, there is one very famous example where he got really stuck and he went to a restaurant. In the restaurant, the plate was a little bit wobbling because the surface was not even. He started to calculate using physics how the plate is going to wobble. And this pushed him in one of the things that was part of the work that got him a Nobel Prize nomination. It was just something that, oh, the plate is wobbling, and I'm going to play with the things that I'm doing. Not treated as work, but treated as play. And this is how he was like motivating himself. And in general, when we have something to do, when we treat it as play, when we treat it as something that we experiment with, that we play around, we find the motivation to be more productive, right? But when the AI tools first initially came up, this is like the first version of ChatGPT, it didn't quite feel that way. We were able to type in stuff, but it was like very cumbersome. You need to always copy stuff from different places. And if you want to create a script that used the API of 3.5, GPT 3.5, for example, it was very hard to work with it. So you want to write a script to build some product on top of this API of this large language model. And it was returning different responses. Even if you say, I want a JSON response, sometimes it returns JSON response as something, and sometimes it says, here is a JSON response. And that it makes it invalid, right? And you cannot parse it every time. It was very tedious, right? And the first step of that I saw, like the first step of these tools becoming more available for productivity improvements was something that was called structured outputs. This was a way that you can instruct the LLM to say, okay, this is the output that I want to receive from the response that you're returning. It was first introduced over API, and it was a JSON schema definition of the response that you're expecting. And the LLM was following it. When you provide a structure output JSON schema, the model was always responding with it. And then there was another revolution, I can say, step 2 in making these things actually useful, and this is function calling. It was also introduced first over the API. Function calling or tool calling, different vendors call it a different way, but it's the same thing. You basically define tools, you give them to the large language model, and it starts using them. It can think about in what context should I use this tool now, what tools I can use. It's part of the training of the model to instruct it to search for tools, know what to do with the tools, know what tools are in general. It's something that gives capability for the large language models to actually do stuff. And this is one example. It's like function definition for getting a horoscope, and you can say this guesses this horoscope for an astrological sign. Very strange tool. And it requires a sign and it returns a string, basically. You say this is the function that you can call, and you provide a description so the LLM knows what it is and when to use it. Then you provide like an input, and when you also say to the ChatGPT-5, for example, here is the list of tools that you can use. We have one tools in the list, but it knows, okay, I can get a horoscope. And then, okay, but how does it work? How does it actually, what do we mean by tool? And then we say, well, we need to orchestrate the tool calling. We tell the model these are the tools that you can use, and sometimes it can reply, I want to use this tool as a response. And we can say, okay, what is the type we get? Is a function call. Is it get horoscope because this is the tool that we're giving it? Yeah, then we execute the logic. We call the function in our code that's called get horoscope. And yeah, it basically gets it and then returns it to the LLM again. It says, okay, here is like your the result of you calling this function. And then we get the final response. We are calling the LLM again. We're saying, okay, this is what the user requested. This is the tool that you wanted. This is the result from running the tool. And now give me the final output. It prints the final output. Basically, every time when you do tools calling, you say to the LLM, here are the tools that you can use. And when it wants to use the tool, it says to the orchestrating code, call this tool, use this tool. And this was like giving the LLM's ability to do stuff, to actually do something useful. And the model context protocol is like building on those two concepts. And it's like the third step of the evolution of making LLMs and AI in general more useful. The structured outputs provided the ability for the LLMs to, like you can think of it, fill in forms. You define the form, and you knows what fields are in the form, and it can fill the form. With function calling, it can press the right button. It can know which form to fill in and to press the right button in order to do the thing that it can do. But with MCP, it can automatically discover all the forms and all the buttons from different tools. It knows how to discover them, and then it knows how to use them. You don't need custom wiring. No matter what different forms in the web equivalent, different tools, if it's Jira, if it's Grafana, Figma, doesn't matter. They all return different forms, and the MCP protocol defines a way for the AI to know how to work with all those forms and click the right buttons. The core principle behind the model context protocol is that it provides dynamic discovery and interact with external systems. Can discover capabilities and actually knows how to use those capabilities. And it's something that was started by Anthropic. They started it as a standard. It was like first people to put it in their products, and then gradually it was adopted by different vendors. First was the AI coding assistants like Cursor, like the Windsurfs and the others. Then it was slowly adopted by Microsoft, by Amazon, then with Google, and then OpenAI was like the last big player, but they also adopted MCP, and they have MCP in their products built in. And somehow it became the de facto standard. When you want to interface your LLM with an external system, in whichever product you're using, there most probably is an MCP implementation. And so do a short overview of how MCP works. So you have some AI-enabled software that you're using. For example, Cursor. How many of you are using Cursor? Show of hands. Okay, a couple of people. So Cursor is integrated developer environment with AI built in. You can say that it has agentic capabilities like every other shiny coding tool out there, but it's an AI coding tool, AI coding environment. So in every such application, you have an MCP client that is connecting with different MCP servers. And you have, for example, over here, we have MySQL MCP server that connects to a MySQL database. And then we have a Jira MCP server and AWS MCP server. And MCP clients ask each of those servers, hey, MySQL MCP server, what tools do you have? And it says like, I can run queries, I can get you a scheme of the table, I can get you a scheme of the database, I can create a user, I can grant permissions, and it says what it can do. And then it says, hey, Jira MCP server, what tools do you have? And the Jira MCP server says, well, you can create a project, list projects, create issue, list issues, query issues, add a label, assign people, create users, change permissions of users, basically all the things that you can do in Jira. And then the same with AWS, for example, you can create a EC2 instance, you can set up an S3 bucket, list S3 buckets, get content of S3 bucket, yeah, all those things. And MCP clients speak this protocol and give this as a context to Cursor so it knows what to do. And basically each of those is connected to their corresponding system. You can have locally running MySQL on your machine, or the MySQL can be in some environment, cloud environment. You can connect to Jira, to your Jira that's hosted in your data center, in your virtual environment, or you can connect to Jira Cloud. And with AWS, you connect to the AWS. So it can connect to, the servers are something that connects to resources running locally or running remotely. And same for servers. You can have servers running on your machine, and you can also connect to servers that are hosted and use them as a software as a service, basically. The company behind it is running it, and you just interface with it. And there are like different servers that you can do. There are different catalogs. Here is one catalog. Every week there's like a new hot catalog for MCP servers. But basically they all do the same job. All the MCP servers are put on GitHub, and they index GitHub and give you some fancier UI so you can search for those servers. And there are like a lot of servers out there. This is the typical setup for using MCP. But there is a problem when you have multiple clients. If you have Cursor and you have Cloud Desktop, and then you have Cloud Code or Gemini CLI or something else, each of them have a different MCP client. This is how it works. And in every MCP client, you need to do the same configuration to connect them to the same servers. And this is like a lot of repetitive work. And also the servers that you're running locally, they're usually Node.js servers that you start up, they're running, and then your application that is using the client connects to the Node.js application in your machine that's running. And how do you manage the lifecycle? How do you upgrade it? It's a little bit cumbersome. So there's like a new approach that's called an MCP gateway. You have one gateway running on your machine, and it connects to all the clients. All the clients have only one configuration. In each client, you just say connect to this MCP gateway. And the MCP gateway usually have the ability to configure it automatically. And you just say it connected to cursor, because it knows where the standard location for the MCP configuration of cursor in the file system is. Same for Cloud Desktop, same for Gemini CLI. And you can, from the gateway, configure the connection to each client. And then in the MCP gateway, you can also manage the connections to different MCP servers. And one great example of such gateway is the Docker MCP toolkit. It's, maybe all of you, most of you, not all of you, maybe most of you are using Docker, and you have your desktop client. In the desktop client, there's like a new MCP toolkit tab. When you click it, first you go to clients, and over here you can say connect to the different clients that you have. In this example, you can see that I have connected it to cursor and something else, okay, but you can connect it, and you also go to servers and you can install servers, and it's very easy because they're Docker containers. Docker manages the lifecycle. You can also upgrade them very easily by using the standard Docker application. Inside the full toolkit, you get the servers and you get the connection with the clients, and it's like very easy way to use MCP. And okay, but what you can do with MCP, and I'm going to give you some examples of different servers and what can you do with them. The first one is around code bases and repositories, and this is like sorry, you can use different servers here: GitHub, GitLab, GitKraken. Context 7 is the one MCP servers that every MCP pro is using. Every person that is like power user of MCP, when I ask them what is like the go-to, like your most useful thing, they all say Context 7, because it provides the most up-to-date documentation of the frameworks and libraries that you're using as context. And this makes the agents more powerful because the LLMs are trained on some versions of the libraries, but when a new version came up, it's not trained on the latest APIs and best practices, and this is what Context 7 patches. And this is one example. You can say, using the GitHub MCP server, create a new branch, push out state changes, create a pull request, add labels, run checks, and post when you're ready, post it as a comment in some channel. And this is like one example output that you can get. It created a branch, it created a pull request, added the labels, added reviewers, linked some issues from Jira Linear or whatever you're using. And you see build passed, unit test passed, but integration test failed, and then you post it to the PR, the integration test failed. This is like nice automation, but you can see that this prompt was a little bit long, right? And you don't want to write it every time. And there is something that's called /commands that you can use in every coding environment. And they're usually called /commands. You have it in Cursor, you have it in GitHub Copilot, basically everywhere. And it's like a /command name, and then you provide some arguments. In our example, we're gonna package this long prompt as /PR. Then you put the branch name, then you put the PR title for the PR, and it automatically calls this long prompt. And you can also combine them. You can say /check compiler errors and /commit and /create a PR. And these all are some longer prompts that you put it in as a configuration in your AI coding environment, and it executes some complex prompts with MCP. But this is like the way to do it. Another thing that I want to show you is an example of using Figma, because a lot of people are asking me, okay, Figma, it's very popular for designing front end. How can we use it to work with it? And there is like a community server that you can use. Community server means that it's not developed by Figma, because all of the other examples I'm showing you are servers developed by the companies that are behind the products, like GitHub MCP server, GitLab MCP server. But for Figma, we don't have like a Figma MCP server created by Figma. But again, you can say, I need you to clone this dashboard. And there is a very nice blog article that basically show the results. And you can see on the right side is the Figma design. On the left side is the Figma design. On the right side is the produced code. And it's getting the job done at 90%, right? It saves a lot of time. And then you just need to go in and tweak it to make it pixel perfect if you want, if this is what you need. You can also use MCP with your continuous integration, continuous delivery workflows. You can say fetch the latest failed build for this environment, summarize why it's failing, what is the likely root cause, suggest a patch, create a pull request with it, and let's try to fix it. And this is one example that you can get. The latest failed build is number 1784, this commit. Here are the failed jobs. Here are why it probably failed. It was an integration test. PostgreSQL was not available when we try to run the test. Okay, so let's open a pull request where we do a health check and then we run the tests. This is something that, an example of interfacing with multiple systems and MCPs in order to get it working. You can also use it for data exploration and for database access. And this is really useful because when we are writing code, when we are designing our software, we need to know what are the constraints of the real world that our software is operating with. And you're maybe designing a feature for a specific subset of users. And you want to ask yourself, okay, how many users are there? Maybe how complex should this feature be? Am I designing a feature for 10 users a month, for 10 users a day, or for like 100 users a second doing something? It's very different, right? And sometimes you dig in the database to see how big the use case that you're working with is. And this is very good to read because you can describe with plain text what you want to fetch. And it's translated to SQL queries and executed against your databases. And yeah, there are different MCP servers for Postgres, for Mongo, for ClickHouse, for DuckDB. You can see that there is no MySQL here because there is no official MySQL MCP client, but there are plenty of community MCP servers for MySQL, and also Data Hub is also a connector to has a connector to MySQL. And also another very cool use cases when you want to replicate some bug, you need to replicate it on a testing environment, and you want to see that with data because you don't want to do it on an empty environment. So you say, okay, get a sample from the production database and load it in this environment. And this is a one example result of running this query. From production, it's loading to staging. It's trying to sample the same users. It's trying to run some anonymization logic to replace the usernames, replace phone numbers, but keeping the same referential integrity. You want to keep all the foreign keys so everything can work, and you can query the data, and then it validates, okay, is it working? Did I get the same number of rows written in the tables that I wanted? And it proposes some next steps. You can also use MCP for browser automation. You can make it click on stuff, execute tests. MCP doesn't improve the capability of the LLMs to write better tests. It's not going to help them be better at writing playwright tests, for example. But what it's going to do is give them the ability to execute them. And you can say, yeah, execute those tests for this use case. This is oversimplified, so it can fit on a slide. It's usually way longer. It's not like user journey. This user journey should be like more well defined. But this is what you can get as a result. Checkout workflow for guest user. It's not working on Safari because payment iframe is not loading. And you know where to dig in. It's basically faster way to run your tests and to automate browser things with your browsers. It can also be a glue between workflows. You can say create release notes for this tag that I have in my Git and connect it with connected with the description of the tasks for these pull requests. And this is like, here are the release notes. These are the features that were introduced, the fixes, the chores, and it's published to Confluence or to Notion, and also summary posted to this Slack channel. It automates like the process of writing release notes, one example. And one thing that you need to keep in mind that I want to, there are two things that I want to finish with. First is don't have too many MCP servers. They bloat the context. Every time when you have an MCP server, the clients are loading the tools definition that is like usually a long list if you're using some complicated MCP server, and putting it inside the chats that you're using, inside the context. So it takes up tokens. It bloats the context. It's also more expensive because you spend more money for the tokens that are the definitions of the tools, and sometimes this happens. Claude is like thinking, okay, let me think which tool to use. He thinks for 30 seconds and he says, I tried this tool and then this tool and then this tool. Sometimes it gets confused. And the you ain't gonna need it principle is super important here. If something you don't need an MCP server, don't just put it there. Be mindful what servers are you using, and if you're not using something, it's better to remove it. And the last thing that I want to finish with is that S in MCP stands for security. You can download some unvetted third-party server. You can steal the conversations that you're having with your LLMs. Sometimes when the MCP server replies with metadata, if there is a prompt inside the metadata, it can execute it as instructions. Authentication is not solved, so usually you download a key, you put it in your server to authenticate against the infrastructure that you're using or system that you're using, and every person that accesses this server gets the same permission or the same authentication that you have. And there are overly permissive scopes. And if you think, okay, how can I get started with MCP server? You can just get your bash history or ZSH history file, put it inside an LLM, give him these instructions based on the things that I'm doing. What MCP server should I consider? Here is my bash history or ZSH history, and some constraints. Be specific. You don't want it to hallucinate that you're using something. You tell it, don't hallucinate. Tell me where in the history cite actual history lines, and here are the list of servers that you're going to pick from. Don't figure out the existing servers. And pretty much that's it. Go and try and use MCP in your workflows.
Thank you very much, Nikolay. Any questions from the hall here? There's one question, and this will be the only one from the hall, because the next one will be from the speaker's corner.
Echo, okay. Can you expand a little bit on the security side? Because MCP is considered a little bit not mature in terms of security by many practitioners. And well, recently we had another exploit forcing, well, sending private emails just because you gave access to your calendar. So there are many of those. So what are your recommendations to stay safe?
Yeah, I think you need to be very careful when you use it as an integration point inside the applications that we're building. It has a very good use case for personal productivity. That's why I'm aiming the discussion in terms of here's how to use it for personal productivity. And you vet the servers that you use. You vet the sources of information that you use. The source of inputs is like you're the source of inputs. The servers are running on your machine and when you have access to them, and or some cloud that are created and by the companies behind the products that you're interfacing with. So yeah, these are my recommendations. You need to be very careful if you provide your users ability to talk to your MCP server. You need to be very careful with it, and there are some recent patches in the standard that try to use different versions of OAuth to try to solve that. And it's not that adopted yet, but I think it's a step in the right direction. We should think about it, think about how to use standard solutions in the industry, and it needs to be more adopted. Right now, there's a lot of work in this direction, so I'm sure it's going to get solved, but there is a lot of work in that direction.
Thank you very much.
Thank you.
So, Nikki and Alex will be waiting for you during the next break in the speaker's corner. Let's now send him off of the stage with big round of applause. Nikolay Stoitsev!